Um, First of all, thank you all for attending this science policy for scientists session. It's very encouraging to see students from various departments showing up here, and I hope to see you all for the next 7, 8 sessions. And I hope something comes out of this. And I'm happy to chat more about this with you all. For the first session, we have Mitch Ambrose. Mitch is the Director of Science Policy, News and Analysis for the American Institute of Physics. He manages the AIP's science policy publication called FYI and set up tools for tracking federal science budgets and legislation. Before joining AIP, Mitch worked on the Senate Commerce, Science and Transportation Committee and was a fellow at the Science and Technology Policy Institute. Mitch, even before that, Mitch received his PS in physics from the University of Minnesota. So to kick off this lecture series, Mitch will describe ways in which scientists can influence federal policy and will highlight some of the biggest science policy issues currently under debate in DC. Mitch, take over. Thank you.
Thanks for the invite and thanks for you all come today. All right, so just in case people just joined the Zoom and didn't hear my earlier introduction, so I've been with AIP for about 7 years now, and my job is to we run a set of newsletters that are actually free to sign up for. So I'll encourage everyone to sign up. It's really tracking the week-to-week grind of science policy in DC. So the congressional hearings, of course, the new Congress just started. And it's going to be really busy a couple of years in science policy, I think. Coming off of last Congress was extremely busy, as we'll get into, and just want to give you a flavor of how exactly scientists try to get their voice heard in Washington, given all the chaos there. So here's a quick outline. I'll just tell you a bit about AIP itself. It's an interesting type of scientific society. In that our members aren't scientists themselves. Our members are scientific societies, and there's a few other models like that, but it's relatively rare in terms of scientific society. Then I'll take a quick tour through different modes of ways that scientists typically try to influence the process, and then do a really deep dive into what's called and it's a bit of a tongue twister, the Particle Physics Project Prioritization Panel, which is a really formal way that particle physicists go about pitching their vision to Congress. And as I was mentioning earlier, it's very similar to the Hale survey process that certain fields of science use. And I think, if you can understand the dynamics at play in any given one of these exercises, it's very transferable to other fields of science. Then I'll conclude with an outlook for some of the hottest topics in DC and look into the crystal ball a bit. And then I was asked to give some career advice toward the end, and then happy to answer questions. So on AIP itself, we have 10 member societies, and this is reflecting that there's no one physics society in the US. You've got AAS for astronomy, Optica for the laser people, ACA's the crystallographers.
Sorry, what is the AIP stand?
American Institute of Physics. And AMS is the meteorologists, ASA is the acoustics folks, AAPM is the medical physicists, and so on. It's just a really broad range of disciplines. And AIP was created in part to who's paying attention to things that cut across all of the different disciplines of physics. So things like preserving the history of physics. We have a big history center at AIP that does oral histories with physicists, and we have a whole archives out in College Park, Maryland. Also, we have a statistical research center that's looking broadly at the demographics of the physics community over time. Things that some of these smaller societies don't have enough of a budget to have a dedicated research program. like that. And so AIP also publishes scientific journals, as a lot of these societies do. And so one of the things that AIP does on behalf of the physics community is we have a science policy news service that I run. So there's the sign up information there. We have a Twitter account, again, free to sign up for. And we're really trying to become a trade publication for science policy, because there's not much reporting on that broadly. And to give you a sense of why it's a good time to sign up, it's, I've been doing this for about 7 years, and the last 2 years were just absolutely the busiest times in science policy I can remember. Coming off of the previous administration, also, of course, a lot of uncertainty around science policy. So just to name a few things, there's the Chips and Science Act. How many, just show of hands, how many of you have heard of the Chips and Science Act? We've got 1, 2, 3, 4. Okay. So this is really worth spending some time understanding. It contains about $50 billion specifically for onshoring semiconductor manufacturing, of which about 10 billion is for research, basically, or earlier stage research. And Congress usually doesn't do this sort of picking out a single technology and saying, this is so important, we're going to plow a bunch of money into it. But beyond semiconductor stuff in that legislation, there's also a lot. It sets out a vision for growing science budgets broadly across some of the main agencies. So like Department of Energy, National Science Foundation. But it gets really complicated quickly because it doesn't include money directly for those things, but it is, in general, it's a push from the Congress to prioritize science more than it has recently, worth paying attention to. Then there were these big infrastructure laws. So if you're in the energy climate space at all, the combination of this bipartisan infrastructure law and then the Inflation Reduction Act, I mean, it's tens of billions of dollars for energy technology development. I would say it's not so much research money, but it's more like how can we prove out certain technologies like sucking carbon dioxide from the atmosphere. And then on top of that, it's hundreds of billions for incentives for deploying renewables and other types of technologies. So just those 3 bills alone are huge, huge things, and they all happened within the space of about a year of each other. And then the Ukraine war having enormous effects on science policy in terms of whether or not different disciplines, you'll still have partnerships with Russia. And I could give a lot of examples of how, science in the Cold War, science was really being used as a tool of diplomacy with the Soviet Union. And in some sense, that's breaking down in the context of the Russia's invasion of Ukraine, in that even in particle physics, where there's this lab in Europe called CERN, which was a place where physicists from the 2 countries could interact, and build trust. Aside from the big geopolitical dynamics, CERN has, because of in reaction to the war, CERN has actually started the process of severing ties with Russian institutions. So that's a partnership that might not survive these times. And then the US-China dynamics, it would be hard to understate how much of an effect that's having on science policy. It's, who's allowed to get visas, what collaborations you can have. That's driving so many of the conversations in DC right now. And I could devote a whole presentation on that, but I'm not going to do that. I'm happy to chat about it more with anyone who's interested later. Anyway, so important time to be paying attention to what's going on. So here's just a quick summary of a lot of the very obvious things, ways you can get involved. We were talking about before. There's going to Congress, CVDs, they're called, Congressional Visit Days. Oftentimes agencies will put out requests for information on given initiatives. You can read the Federal Register, and there's always some sort of request for comment on some research program. Then there's these disciplinary prioritization processes I was talking about earlier, where like the decadal surveys and P5s. And I'm really going to spend a lot of my talk on this because they really are so important in terms of how scientists get heard in Washington. And oftentimes those are run by formal advisory committees for different science agencies. And so this is one way, especially if you're planning to stay in academia, one of the ways you can have a pretty big influence on a given program is by serving on one of these committees. You keep your professorship and you volunteer some of your time to give advice to agencies. Then, of course, there's congressional hearings, giving testimony. Of course, you have to be invited for that, but that's Congress. There's, for example, in the House, it's called the House Science Committee, and they have dozens and dozens of hearings every year, and that is a big advice mechanism. And then, of course, lobbying. Service in government itself, I think this is something that is underappreciated. I'm going to highlight a specific example of a person I think who's had more influence on science policy than most people, but is very doesn't have a very high profile. I'll return to that. And then ultimately you can run for elected office. So just as an example, there's one physicist at Congress right now. I think the peak was there was 3 about 10 years ago. And there's a lot of medical doctors and so on, but relatively few actual scientists.
Wait, do you know for scientists as a whole?
For physicists, there's just one physicist. There are, I don't know the latest statistics. For a while, there was a mathematician. I don't think there's any astronomers currently. It tends to be a lot of medical doctors, some engineers as well. So here is now diving into one of these prioritization processes. And again, this is the P5 process. And basically, it's a way of, in the US, you've got thousands of particle physicists. How do you come to a consensus on what do you want to do next in terms of, for instance, facilities? Of course, any one of these really big colliders is probably more than $1 billion. And that can really start to strain resources. And so how are you going to tell a bunch of people in Congress, only one of whom, there's about 535 members of Congress, I think, no, there's exactly 535 members of Congress. One of them is a physicist. And so how are you going to convince them to put more than $1 billion to build a very esoteric machine relative to all the other things they could be spending the money on? And so what this community of science has landed on is, okay, we need to have a very unified message when we go have our pitch to the Hill. And it's named, it starts with this big week-long workshop, and it's called Snowmass because the first one was held in Snowmass, Colorado, but now it's just held around the country. And they just had this last summer where they really, had a bunch of very, tough conversations about what we want to prioritize. And then just last month, I have a link to the PDF at the bottom there. They came out with a report that has priorities, both for, I'm going to focus on just facilities, but there's also scientific priorities, like what are the key scientific questions we're trying to answer. And this is one of the summary tables at the bottom of really big things. So one of these is you might have heard of the Gravitational Wave Observatory, LIGO. One of their priorities for the 2035 to 2045 time frame is a next generation gravitational wave observatory. Now we're talking, this is more than a decade out. I mean, it's in some sense, it's like, wow, that's so far away. Like, are they really, is the planning starting this early for this sort of stuff? And yes, it's like even more than a decade out. They're starting to lay the groundwork for these types of facilities. And so it's not meant for you to read the fine print on this, but this is an example of about 10 years ago, they did one of these P5 processes. Each one of these is a big project, basically. And this is a progress bar on, of all the things that they pitched the last time around, here's how far they've gotten. And this table's included in that report that I linked to on the previous slide. And this is partially to say that they pitched a vision, and a lot of it has been implemented in the time since they pitched this vision, which they do show this as a mark of the success of the process itself. Last time they ran it, a lot of the stuff they wanted to build, they were able to build. And so now they're getting into, for this iteration, the second half of the P5 process, which is the first meeting was this big conference with hundreds of people. They distilled that down into a 100-page report or so, summary report at least. And now they have a panel of 30 people who have been, this is where the money discussion really comes in, where the previous report was a blue sky vision, like don't think too much about how much this is going to cost, like really tell us what the most compelling science is. This panel is chaired by this guy at the right, of about 30 people, is now going to be, they've been tasked by the agencies themselves, so National Science Foundation, Department of Energy. Okay, we're giving you a budget constraint, and one of them is 2% per year for the next 10 years. Within that budget envelope, what do you think we can afford? And that starts to get even harder sorts of discussions. And that process is literally taking off today. Somewhere is a private meeting where they're kicking off this meeting. That's part of the reason I picked this as an example, is that it's really happening now. And want to give you some reflections of someone who's been involved in these things before. This is the person I was telling you about earlier, who I think has had an absolutely huge effect on science policy, working within the government, within the Department of Energy Office of Science, which funds lots and lots of physics research. That she was one of the executives in that office for a long time. And I've heard multiple people say that she's been one of the most influential people for physics research projects in the US. This person was really key to getting the budgets for different things. And there was a meeting last November. I put the link in at the bottom. For anyone who's really interested in this sort of budget politics stuff, I really recommend listening to her presentation at that meeting. And I've excerpted some of it here, where she's reflecting on when Congress is hearing from scientists about what their priorities are, what are they listening for, and what actually, and this is, forget about particle physics for a second. Just think about, first, people are going to Congress to try to pitch an idea, and how is Congress going to be receiving that advice? And in this case, you've got this report. Here are all the things we want you to spend billions of dollars to do, what they're thinking. And she says, congressional input is gathered from people who go in and talk to the appropriators. So this is the people, there's certain committees that really control the budget. They're the appropriators. And quite frankly, if you don't have a consistent message among all the people who are going in to talk to those people, you're going to fail. And basically what this means is that this whole P5 process is designed to build consensus. And then you go pitch your report to Congress. But then if other physicists who maybe didn't like how the report turned out, or they didn't do a good job of building that consensus, if other prominent physicists start kind of whispering in the ears of these appropriators, being like, well, we really should be building this thing. They said to build this thing, but let's build this thing. And that actually happens quite a bit in different fields of science. I've heard this was apparently a huge problem for the fusion energy people for a long time, where they couldn't agree on what they wanted to build. And so Congress was hearing different factions of the community would be like, oh, we want to build this device or this device. And they're like, you know what, you guys don't have your act together. We're not going to build anything. That's basically what happened. That the budget for fusion for a long time in the US was just stagnant because of that. And same thing with particle physics, where they couldn't agree for a long time on the really big things they wanted to do, and the budget was basically flat. And another one of the reflections here was, what's the audience of these reports? And in a sense, you are trying to convince the general public of your vision, but she, as someone who's observed this process playing out, she's at the end of the day, it's not the person on the street that goes in and talks to Congress about particle physics, or they're talking about healthcare, they're talking about poverty, they're talking about education. Just science is so far down on the list in a lot of cases of what your average member of Congress is hearing about. And so for these fields of science, it's oftentimes relatively small communities of people, experts, who are talking to a handful of people in Congress that have, sit on very specific committees that actually control the science budget. And it's really, there's a conversation to be had about getting Congress broadly to appreciate the value of science. And setting aside that conversation, when you're trying to get a given agency to fund a given project, it's really just a handful of people that you need to convince. And it can be kind of scary how small the number of people is. And who are those people? Here's some example of, there's basically, for most of the non-defense science in the US, there's basically, I'm not including health committees here for like NIH, this isn't including NIH, but if you're funded by NASA, National Science Foundation, Department of Energy, those agencies, it's these 4 people in the House, and then there's 4 people in the Senate. And together it's the top, there's the top Republican and Democrat for the Energy Water Subcommittee that controls DOE funding. Commerce, Justice, Science is NASA, NSF is mashed up with Department of Justice, and the jurisdictions don't necessarily make sense. It's just they had to slice up the federal budget somehow. And so Department of Energy happens to be in the same part of the budget that funds the Army Corps of Engineers. And so they're having to make trade-offs between, particle colliders and dams for rivers. It's really the types of trade-offs that have to be made. And it's these 4 people in the House, and there's 4 more in the Senate, that if you want to get a particle collider built, if you can get those 8 people on board, and if they themselves have enough money in their budget, there's the macro discussion of what is the size of the federal budget going to be in total, and then each of these committees gets a slice of it. If they get enough of an increase to their slice of the budget, then they can start doing new things. And so if you can convince them of your vision, then you can really make change. And so in that sense, I say it's kind of scary that it's relatively few number of people that control the budget for really big projects. And these reports, the decadal surveys, the P5 report, it's all about having a fight within a given discipline of science in private, basically, agreeing on the message, and then pitching it to these people. So that they're not having people whisper in their ears about other things that should be done. And at the bottom here, one of the tools we have on our website is an index of the really important people. So here's some more from the reflections from that same person, where basically she said the last time they ran this process, the P5 process, it actually worked really well. And then, just so that you're hearing it from a veteran and not from me, the second quote there, if everyone is going to Congress pitching their own little thing, what happens is that Congress simply defers the decision because there are so many opportunities for appropriators or an agency to invest in things that aren't contentious. If you haven't figured out what telescope you really want to build, we might go use that money to build a new headquarters for the FBI. I was serious because the FBI is funded out of the same bill that funds NASA. And it's these, the history behind why it got sliced up that way is who knows, but that's how it's landed. So anyway, this is DOE itself now points out like, okay, we were in the wilderness for a while, pretty flat budget. We pitched a vision, and then now it's starting, there's a time lag for a lot of these things because of how long it takes the budget process to turn over. But now they feel like, okay, our budget has really started to go up after we pitched this vision. And so I gave all that as an example. I tried to pick a concrete example of how a given field of science tries to influence Congress. And I'd say this is solidly in the camp of what's known as policy for science. And then I haven't talked at all about the other side of the coin, which is science for policy, which is, how do you get, that's much more relevant for things like climate change, where you have a conclusion about, hey, we have a problem here, and how do you convince Congress of that conclusion? I actually think that's much harder. So I just like to get that to resonate. So I actually decided to focus my presentation on policy for science, because I think it's a bit more understood about what is effective in those cases. Anyway, shifting to other, this is more about hot topics in DC and things to be thinking about. Potential topic areas if you're trying to, going on a congressional visit day, or wanting to weigh in on something yourself from your own perspective. These are we do this annual story for my publication where we try to pick out what do we think some of the big stories of the year are, and to just give you a flavor of what's going on. So there's first one, there is this phrase called industrial policy is being thrown around a lot in DC. And that's basically those three big pieces of legislation I mentioned earlier: the CHIPS Act, Infrastructure Bill, Inflation Reduction Act. Those are viewed as industrial policy bills, picking out specific sectors of the economy to shore up, basically. Whereas the US for a long time was more hands-off, free market. Coming out of the pandemic, all the supply chain issues we had, and so on, there's a lot more interest in supporting really critical sectors. Then, of course, now we have a divided Congress. Republicans have taken over the House, and they have pledged to restrain spending overall. They haven't said we want to cut the science budget by this amount, but they say we want to cut the overall budget by quite a bit. And I think I'd be very surprised if science is not going to be, the proposal at least, I think from the House, is going to be a pretty broad scale back of funding. And I think in that context, it's going to make it, a lot of those people I had on the screen earlier, the appropriators, a lot of those people actually, they have on both sides of the aisle, they have very favorable views towards science. But at the end of the day, they get a number that is flowed down from their leadership. And the number might be to cut their part of the budget by 10%. They probably don't want to do that, but they're going to have to come up with a proposal that makes the numbers work. And that's when having a clear list of priorities becomes even more important for a given field of science. And part of these reports is so that oftentimes there's a rank ordered list of, well, if you don't have enough money to build this thing, at least build this thing. They're called decision rules. Anyway, I won't go through all of these. I know I'm running out of time a bit, but I mentioned earlier that the US-China dynamics are having huge effects. The phrase is often used is called research security, which is basically, how do you, even in areas of more fundamental science. I mean, for a long, research that companies is doing is obviously viewed as having a more direct economic value. So there's long been, concerns about industrial espionage. But now the conversation around protecting research is increasingly moving towards academia. And that a lot of what's going on in academia is potentially very valuable. And there's been an impulse from some parts of the government to want to basically fence off more of academia, and basically concerned that the US is falling behind. But then there's also a lot of scientists, and this is something that a lot of scientific societies have been doing, have been trying to point out to the government that in the US especially, in some disciplines, more than half of the graduate students are from outside of the US. And that if you really close the doors, you might end up undercutting your advantage. And so those types of discussions are very active in DC right now. And I can get into that more later. Fusion, you might have heard in the news, there's the big laser facility out in Livermore that generated net energy, but it was net energy from the lasers that, if you don't count the power it had to take from the grid to shoot the fuel capsule, it was net energy generated. And that got a lot of press. And so now people are like, oh, we're going to have fusion in 10 years or so. And I think that there is this surge of optimism about the field, but there's going to be, I think the fusion folks don't want to overpromise necessarily. And that's an interesting case where you get a field of science that's thrust into public view in a way that it hasn't in a long time. And how do you try to channel that energy without overpromising? That's playing out in quantum computing, it's playing out in fusion. And so that's a story to watch. And in the interest of time, I'll keep moving, but there's a whole article, again, the link, you can go to our website, it's available. And then before I pivot to questions, I was asked to give some career advice generally. And this is, I started in undergrad, I was doing particle physics, and these are Feynman diagrams for ways that the Higgs boson can be produced. And just by sheer luck, I was in undergrad. I did a study abroad at CERN, and I happened to be there when they announced the Higgs boson discovery. So that photo there is, I took that when they had the press conference there for the announcement, and that was my blurry photo of Peter Higgs. And so this is a security guard. It's the first time I've seen a scientist have a security guard, and he was being whisked away from the conference room. And that's the moment that really I found that I was, when I was honest with myself, I wasn't all that interested in what does the discovery of the Higgs mean for the standard model of particle physics. I was much more interested in, how did they get all these countries to come together to build this machine? And it's just a really neat place. You have people from all around the world. And I found myself, like, if you're much more interested in like these management of science questions than you are in the science itself, I took that as a very strong signal that, okay, maybe your heart is elsewhere. And the advice I have on that point is like, think about what interests you most about science in thinking about your career focus. And for me, it was basically, I ought to change course. And so I flew back to the States. This is going into my senior year of undergrad. And then one of the first things I did, that's a picture of the Minnesota State Capitol. And I'm like, well, I need to get some sort of sense of what policy even is. And I just got a unpaid internship in the state capitol, convince myself, okay, this is interesting enough. And then my big break, in a sense, and I think this is always one of the trickiest steps to get into science policy. Like, what's your first real hands-on experience? And I was able to find a fellowship program. It still exists to this day, actually, at the Science and Technology Policy Institute, where it's specifically for bachelor's or master's degree graduates. And you don't have to have any prior policy experience. And so you can just jump right in, basically working as a research assistant. So I did that for 2 years. Then the fellowship ran out. And so I basically started cold calling. There's committees in Congress that control the science policy. One of them is the Commerce Science Transportation Committee. And I just cold called them. They didn't have anything advertised on their site about internships or anything. But I was able to find something there. I said, hey, I've got a science background. Can I help you out in some way? And thankfully they took me for a little while, but I wasn't successful in getting a long-term position there. And then I landed at AIP, where I've been since for about 7 years. And so once you're in DC, there's a whole constellation of trade associations. There's the university associations, there's the national academies, lots of organizations that are representing scientific institutions. And there's a certain amount of job opportunities there that can also be a foot in the door, or a place you can really carve out a career. So with that, I'm happy to switch to questions for us.
A lot of them were so.
And the very back there.
So the P5 strategy, I see the trying to put together the primary. What was the pitch then to convince the committee that was worthwhile?
So they have what are known as science drivers, and they picked, I think in the latest process, they picked 5 pressing questions. In one of the, let me move back quick. You can't really see. In the previous go around, they boiled it down to 5 scientific questions. So one of them is identify the new physics of dark matter, understand dark energy and inflation, pursue physics associated with neutrino mass. I mean, obviously, an average member of Congress isn't going to understand what that means, really. But they wanted to pick, don't have too many science priorities. And then in some part of the report, it's written in a way where you can give a general sense of why is this an exciting area of science? Like, oh, of the observable universe, there's obviously a lot more out there that we don't know. And that might be enough of a message to get, this goes back to what I was saying earlier about how do you convince Congress of the values of it's really fundamental research. And that is tricky, but you look at all the public attention that the James Webb images got, and how there's cases in which even that type of science can really it's just the general awe of it can be enough to be like, oh, that's sure, we'll put money towards that. But there are one example that comes to mind is that one of the people who used to be for the Commerce Justice Science Committee, about 5 years ago, the person who was the chair of that committee in the House was this guy, John Culberson. And he, for whatever reason, got really interested in astrobiology. Like, what would it take to find evidence of organic life out in the solar system? And he just got like, someone must have developed a personal connection with him, maybe someone in his district. Well, there could be parochial reasons too. I mean, some of these people, JPL was not JPL. Johnson, NASA had a huge footprint in Texas, still does, Johnson Space Center, and a lot of the people who end up. So this guy, in his district, is Oak Ridge National Lab, which is funded by the Department of Energy. So it's like, there's a reason he wanted that seat. But that said, sometimes you can just get these people's interests. And in John Culberson's case, he single-handedly funneled hundreds of millions of dollars to a planetary probe to Europa, which is an icy moon of, I forget, someone might know, icy moon of Jupiter that there's some strong sense that it might be a good candidate for finding life. And basically, he single-handedly steered a ton of money towards it, so much so that he was actually like wanting them to do it, wanting NASA to do that much faster than it was ready to do it. And so that's kind of an extreme example, but I think a lot of it is just developing, capturing the imagination of people who don't necessarily have a science background, but that you can, through a combination of appealing subtly to their parochialism, like this will be good for your district, but also like, hey, isn't this amazing? I think there's no single recipe there, but that's one way it's played out in the past. Yeah, I mean, there's the broad debate going on in DC about what's the right size of the budget. And I don't think scientists are in a good position to influence that conversation. I think it's more important for scientists to within their part of the federal budget, really making a very strong case for why does this have value for the country or the world, and focus on that message, because it's just extremely hard to influence the bigger debate about the overall size of the budget. So you just want to, when these hard choices have to be made, that's why it's so important to have a consensus view. And it goes back to really that second quote there, that they'll probably just defer the decision, or they might cut your program if you haven't clearly articulated what you're trying to do and why it's important. So I know that doesn't quite answer your question, but I don't know enough about these macro budgetary debates that are going on above my pay grade.
Hey, Mitch, sorry to interrupt, but could you repeat the questions for people on Zoom? Because it's impossible to hear what other people are saying. Also, just a quick plug that there's a session about how the budget is sent from the White House to Congress, if people are interested in that later too.
Great,
Later down.
thanks, Barbara.
Yeah.
I'll try to do better at repeating the question. Does anyone on Zoom have a question right now? Feel free to just jump right in.
In the meantime,
Okay, another one in the room.
I wanted to ask if you could talk a little bit about the effect that the election cycle has on your work. I mean, you get a new Congress every 2 years, potentially you get a new administration every 4 years. I imagine that you might have to shift your priorities. Like, how does that affect the work that you do?
Yeah, it has huge effects. With right now, what we're going through is a lot of these. The key question is, how are they going to fill out these committees? Who is put in charge of the key committees for science? Understanding those people. So we're doing some articles about looking into their background. But then there's also, as you said, the president. Oh, sorry, I need to repeat the question again. The question was, how much is my work changed by changes in the be it the presidential administration or controlled Congress, and the 4-year election cycle for the presidency. And yeah, I mean, especially when a new administration comes in, just totally different set of oversight priorities or budgetary priorities, and trying to think of some good examples, like the past 2 years. This discussion around industrial policy, the Biden administration just really, well, it was a lot of things happening at once. The Biden administration was really pro-industrial policy, but then also in Congress, there's an increasing number of people from both sides of the aisle that embrace the concept. So you really do need broad agreement to do big things. But an exception to that was with the Inflation Reduction Act. That was a unilateral thing where there's a maneuver called reconciliation, where if you can circumvent in the Senate, you usually need 60 votes. But through this special arcane procedure, you only need 50 in certain circumstances. And they were able to push through ideas that didn't have broad support. And so in that sense, that was never, except in the first 2 years of the Trump administration, Republicans controlled House, Senate, White House, and they used reconciliation at least once. They did a big tax package, tax cutting package, basically. But then 2 years later, the House flipped, and so then that tool was taken away from them. And so I think this Congress is probably going to be less active than the previous one because that tool has been taken away. That's a procedural example, how it can change.
I'm curious about like the crosstalk between international relations, and which big projects are getting funded, and also does that, like, do committees like P5 have to consider that in their pitches year to year?
So the question was what are some of the international dynamics around like the P5 process? How do what other countries do influence those activities? Did I capture that right?
Yeah, kind of, and like who's working in that realm?
And who's working on in that realm? So for a field like particle physics, that becomes really important because it's a really international field. You've got CERN in Europe, which is the center of, the US. There was an attempt in the 90s to build this thing called the superconducting super collider that would have really cemented the US as a hub of particle physics, but this is a whole nother presentation. That project was canceled, and basically the center of gravity of particle physics went to Europe. And so you really need to coordinate with the Europeans these days. Not to mention, certain countries just have very strong traditions in the field, like Japan, increasingly China. And so there's probably only going to be enough political capital in the entire world to build some of these colliders. And so there's this kind of dance that goes on around certain countries are debating hosting certain, so there's this thing called the International Linear Collider that Japan has considered being the host nation for, but they haven't quite committed to it. So if Japan decides they don't want it, then it's like, okay, maybe you're probably only going to build one of them somewhere. And so some dynamics I think are unique to the discipline, but also I think in general, what the US went through a period where in so many fields of science, it was very, it was leading or, had a big reserve of capabilities that other countries didn't have, but increasingly that's becoming not the case. And I think that's not necessarily appreciated in certain corners of the government, or it's being appreciated in a way that's counterproductive. This is all to say that the US, I think, is having this moment where it's realizing that it can't, a lot of other countries have started to put a lot more money into science, and it's just not reasonable to think that, you're just going to do it all yourself. And so the US arguably hasn't done a very good job at, being like, okay, we'll do this, you'll do that, and we'll be okay with you taking the lead on that. And, there's a tendency to want to have ownership over a given thing. And so there's a lot of strain going on around those types of questions right now. But it's very field specific, I'd say. Other in the back there.
Yeah, I'm just curious, based on what you just said at the end about, the US not doing a good job of saying, I will do this to get this. I mean, is there any kind of talk between international legislatures on this kind of thing in terms of planning for we'll do this, huge science project? And if not, does that happen at least in the science realm, if not in the actual legislature appropriation realm?
So an example, I just want to make sure I understand. So an example of where that has been recognized, that you'll do this, we'll do this. So can you just restate the question?
Yeah, it's just is there, I guess, do different countries, legislatures or people who call science that talk to each other about planning,
Okay, so the question was, do other countries ever, legislatures of other countries talk, across different legislatures with each other about how to coordinate these sorts of things? Well, one good example is there's this big fusion facility over in France called ITER, and that facility, it's actually basically, it's almost at the level of a treaty where there's 9 countries or so that are they have a very defined share of the budget goes towards building this huge fusion research facility. That was done out of a recognition that this is probably too expensive of a project for any one country to do. But also it was conceived of going back to the Cold War, and it was involving Russia, as well, Soviet Union at that time when it was first, the idea was hatched. And so there was an element of just the act of doing this project is going to bring countries closer together. So there's some examples like that. But I've actually heard of, that's a case where you have a bunch of countries that have a relatively equal share of responsibility. So it's like, if it's everyone's project, is it anyone's project? They've had a lot of management challenges. And so sometimes it's actually preferred to have one country that's the clear lead host and has more of the management authority. And then you have other countries pitching in smaller amounts. And so you run into these really tricky management of science issues. And also I've heard like foreign conversions of currency for when you're paying for these international projects gets really actually kind of tricky. And even shipping the facility components leads to challenges too. So there are trade-offs. So yeah, good question. I'm sure that there's many more examples, but my expertise is, well, my expertise is mainly on the US itself. So in some sense, I'm a symptom of this dynamic where we don't know about what goes on elsewhere as much as we should.
Thanks.
Can you check if there's any question or Zoom?
Yeah, any questions on Zoom? Feel free to just unmute and chime in.
I think I have a question. So I get a sense that a lot of the initiatives, maybe switching gears a little bit, a lot of the initiatives that AIP has been promoting, like the Congressional Visit Days and all of its other organizations in the umbrella, like APS, WAS, are restricted to US citizens. But from my experience, a lot of international graduate students also want to participate, and congressional members tend to be receptive to talking to international students who are studying in American universities if they come with an American peer to their congressional visits. Is there a plan for AIP to expand that, to try to target this other, I guess, demographics? Because 50% of graduate students in STEM in the United States are international students right now.
Yeah, that's a great question. And I, just in case anyone didn't hear, the questioner was asking for the professional societies for science. A lot of their programs are limited to or focused on US citizens, bringing them to congressional visit days. The questioner was asking about, is there any initiative to bring in more international students, given how, in some fields, more than half of international students are abroad. And that's, I heard this same type of topic come up just last month. American Physical Society had their annual business meeting, and one person there was pressing them to incorporate more international students and have programs that are specifically designed to include international students in these sorts of policy opportunities. And I know that it's being thought about in the leadership of APS. And in particular, if I can recommend to you, APS has a government affairs office that they have some campaigns underway about the value of immigration to science and pushing back on certain restrictive research security policies. And I think they're very much receptive to getting more voices of international students reflected in their advocacy campaigns. For AIP itself, we're kind of an interesting case because we don't have, our members are societies themselves, so we don't have that direct membership. And also at the moment, in the past, we've had a lobbyist on staff, but we actually have in the moment, we don't, and we're focused on, so my job, for instance, I don't do any advocacy at all. My role is strictly, I run this news service, and so we're not trying to convince, right now, we're not organizing congressional visit days ourselves, although we have done that in the past. I hope.
Thank you. Yeah, that answers my question. Though AIP does accept international students for their congressional fellowship, which the other organizations that are under the umbrella do not. So that's interesting too.
That's great. I didn't know that about the eligibility criteria. How much
Do we have time for two more questions?
I'm wondering, like, these members of the subcommittee, why are they able to, like, find billions of dollars to, like, something that they're personally interested in? And shouldn't there be some conflict of interest, like, stopping them from doing that? And then my second question is, like, is there a website where we can see the projects that have been suggested? for people?
Mhm. Yeah, well, there is, sorry. So the question was, how is it that some of these like appropriations members are able to funnel so much money towards projects that are, benefit their district, for instance? Isn't that a conflict of interest? And arguably yes, but also there's in Congress, there's a long tradition of, it's known as earmarking. And it's this trade-off of, members of Congress will argue to you that they understand the needs of their districts more than, Congress broadly. So they say, well, we ought to be able to steer money into our own states because we know, this university needs some upgrade, why can't I put the money towards that? But then there's another camp that says, well, there's so much wasteful spending. This is non-competitive. It's just one person deciding. And so Congress actually got rid of earmarks for about 10 years. But then about 2 years ago, they brought them back. And part of the reason they brought them back is that they actually can provide a certain amount of grease on the wheels of, because if you know that this legislation it gives you an incentive to vote for things, basically. It's like, okay, well, you're getting money for your university, I'm getting money for mine, like there's something in it for everyone here. And it's one of the more seedier aspects of the process is that if there's something in it for you, then you might be more likely to reach a compromise. And a good example of this is that the chair of one of the top appropriations people, he retired last year after he had been in the role for a long time. And you can look, it's on a public website, so they added some new transparency where you can see this person, since he led the appropriations committee, he got $45 million for this university to build a medical center, $20 million for this university, like all in his state. And you can see his name is attached to it all. And in some sense, that's Congress itself has decided that allowing members to make those sorts of decisions helps people get along, basically. But the pendulum might swing the other way on that, and they might take them away again. But that's not to say that even if like official earmarks are taken away, there are still what are basically like, there's not a name for them, but if you control one of these committees, you can put things in the bill that to influence the direction of it. So that's always going to be part of the process. So like if you, like the guy who has Oak Ridge National Lab in his district, there's no way that he's going to propose cutting funding for Oak Ridge National. He's just not, it's just totally against his political interests to do that. And so is that a conflict of interest? It's hard to say. In a sense, he's protecting his interests because he represents that lab. But at the end of the day, there is some checks and balances in that, you ultimately do need a vote, everything has to be passed through the whole chamber. So if enough people are like, hey, and that's why like one of these people can't say like, oh, I'm gonna spend $100 million on this facility. That's probably too large. Because then you do have the top line constraint of the budget. So if one of these people tries to steer too much money towards something, other powerful people in Congress are going to be like, well, no, that's too much money. So there are checks and balances within the system itself. It's just certain things. It takes a while to get used to like what's a small amount of money in Congress. It took me a long time. It's like, a couple $1 million, tens of millions of dollars here or there. That's like a rounding error in the congressional budget, where it's like more money I'll ever make in my lifetime. But it's really once you start getting to in the hundreds of millions and beyond, that people really start paying attention to like, okay, what's the justification for this? That's not to say that nothing is like that. There is a lot of vetting that goes into what makes it in, but it's vetted by people with particular interests. Anyway, so that was a long answer, but it's a really, I think, important dynamic that goes on.
Thank you all for the very dynamic discussion. I encourage you all to sign up for the next 1 or 2 hours, which is available to chat with them on any of the issues people remember. Thank you so much for